All right, so the next type of reaction that we're going to talk about is going to be our double replacement reaction. Okay, and just a reminder for what this one represents, it's going to be a compound, so let's just call that compound AB, and that compound is going to react with a new compound, CD. Remember, all of these compounds are going to be metals and nonmetals. So here we'd have our metal, because metals are always listed first, which means B would be the nonmetal, C would be the metal, and then D would be the nonmetal. Okay, and those are going to create two new compounds. So basically the current ionic compounds are going to break apart. So A and B will break apart, and they're going to, and C and D is also going to break apart, and they're going to find a new match. So the metal here, which is A, is going to find the nonmetal in our other compound. So it'd be AD, and then our nonmetal here is going to find our metal there. So, and of course, metals are always written first, so it would be AD plus CD, or CB. Okay, so it's going to be compound plus compound gives us new compound and new compound. For this, we do have to use what are called the solubility rules. So just like single replacement reactions, ionic or double replacement reactions don't always occur. Okay, because sometimes what happens is that these two compounds, when they break apart, when we react it within water, they'll actually just stay in ion form. So they actually will be happier dissolved in water than they would finding a new nonmetal metal counterpart. So when this happens, we have no reaction. To figure out this, we need to look at our solubility chart. Okay, and just a reminder, so soluble means that something is aqueous. Okay, where insoluble means something is going to be, and we're just going to call this a solid, that something's insoluble. It can also be a gas or a liquid, but we're going to call it solid. And just a reminder, aqueous is not the same thing as liquid. Aqueous, for example, would be if we were to put salt in water, that water or that salt is just going to decompose into ions within the water. So that's what aqueous means, is that instead of Na and Cl staying together, they're going to break into ions, and so they're going to keep their octets, but they're going to break apart, and they're going to remain just a solution. Okay, so again, it does not mean that sodium chloride is going to be a liquid. It means that we took salt, we put it in water, and in that water it stayed as an ion. Okay, so that is important because something that's a liquid is a state of matter. Aqueous means something's dissolving. So we're going to use this chart to help us figure out if a reaction occurs. If both of the products are going to be, if both of our products are soluble, meaning aqueous, that means that there is no reaction. So if both products are AQ, that means no reaction takes place. We would not see bubbles. We wouldn't see a solid, a liquid, a gas form. Everything's just dissolving in water, and that's all that's happening. So we'll go ahead and do a couple examples together. The one thing I do want to remind you is that H and OH make water, and water is a liquid. So water is a state of matter. So just make sure you're making note of that. Liquid and aqueous are not the same thing. If there's a gas, it'll tell you that it's a gas. So if you're using the solubility chart, you're assuming it's a solid. So we need to make sure that we're including our states of matter here, since if both products are aqueous, no reaction takes place. We need to make sure that there's a solid, a liquid, or a gas that will form. So we'll start with HCl and NaOH. So my recommendation is to look at everything as a metal and a nonmetal. So just kind of looking at what ions they form here. So for example, so we'll start with HCl. So we know that HCl is, I'm just going to write down here. All right, that's made of H plus and Cl minus. So we know we have our metal and our nonmetal. Okay, Na is Na plus 1. Okay, so that we know is a metal because cation is always metal. And then OH I know is a polyatomic, and that polyatomic is OH minus 1, which means that OH is going to be a nonmetal. So remember, a metal in one compound is going to want to form with a nonmetal in a new compound because they're trying to make new things. So right now our HCl, our hydrogen, is currently with with the Cl. So we don't want to put it with Cl again. So we want to find a new nonmetal to put it with. So if I look over here, I see, okay, well, my other nonmetal in this reactant is OH. So I'm going to put H and OH together. And remember, H and OH make water. So I'm going to write H2O. That is a liquid. That is not aqueous. So that means that this reaction is going to take place because a precipitate liquid is formed. Okay, so we're making a solid, a liquid, or gas. Reaction occurs. So now I know I need to find out the other product so I can balance it. So I want to look at my other two options. So here, all right, I have chlorine I haven't used yet, and I have sodium I haven't used yet. So I have my metal and my nonmetal. Remember, metals always go first, so I'm going to make my new compound. Okay, I'm going to make sure I crisscross. I'm just going to do some scratch work on the side. So Na is +1, Cl minus is -1. Metal goes first, always, always, always. So my second compound would be NaCl. So that would be our second compound. So now I want to look at my solubility chart to figure out, well, what state of matter is Cl? So I want to look here and I see, okay, well, substances containing Cl are soluble unless they contain Ag, Pb, Hg, or Cu. Well, this one doesn't. It has Na. So it means soluble. Remember, soluble means aqueous. So I go back here and I know that this is aqueous, which means that that salt is going to dissolve in the water. But because we made a new state of matter, this reaction takes place. It's already balanced. So we'll go ahead and do a couple more. So I'll try one more. We'll do two more together, and then I'll have you try one. So again, the first thing you want to do is you want to write down all the different byproducts that you're going to have. So I'm just going to underneath it show my work. I'm going to write, okay, I have Na +1, NO3 -1, K is +1, acetate is C2H3O2 -1. All right, so I know that this is a metal, nonmetal, metal, nonmetal. Okay, remember these are all ionic compounds, so metals are going to form with nonmetals. So I'm going to pick my first metal. And I know it has to go with a nonmetal, so it's either going to go with NO3 or C2H3O2. Well, I'm not going to put it with NO3 because it's already with that. It doesn't want to stay the same, so it's trying to switch things up. So I'm going to find the other nonmetal, which is acetate. And I'm going to put it with C2H3O2. So I'm going to go down here. I'm going to show my work over here. Okay, so I know Na is +1. I know acetate is -1. Okay, so I'm going to write my compound here. Crisscross those charges. I know I need to find the state of matter, but I'm going to write my other compound first, and then I'll write my state of matter. All right, so I'm going to match the other ones. So I have nonmetal and metal. Perfect. So I'm going to put those together. Okay, so K goes first because metals always go first. NO3 is -1. So I'm going to crisscross those, and I get KNO3. Okay, I'm just crisscrossing charges. Subscripts never get carried over. All right, so I need to find acetate and nitrate on my list. All right, so we have acetate. Okay, well, it says it's soluble unless it's with silver. Well, ours is not with silver, so we know that this is going to be aqueous. NO3 was our other one. That's also soluble, which means aqueous. There are no exceptions to that one, so both of these are going to be aqueous. Since both of these are aqueous, this is not going to take place. There is going to be no reaction because everything's just going to stay in ion form, and there's actually going to be no compounds that are formed. So it's actually going to end up looking more like my work. So it's going to stay all in ion form. So now we have number 19. So we'll do one more together. So this one's a little more complex, so I want because it has subscripts. So we have NH4 subscript 2S. So again, I'm just going to show my work. I'm going to write NH4. I'll switch colors. So we have NH4 as +1. Sulfur is -2. We are not caring about that 2 there because that's due to sulfur. All right, I'm going to write, and then I know we have metal, non-metal because positive, negative. Okay, Mg, I look in the periodic table. Okay, that's +2. Iodine, -1. All right, perfect. So now I'm going to label metals, non-metals. All right, I'm going to figure out what's going together. So I know my metal is going to go with a nonmetal. So ammonium is either going to go with sulfur or iodine. I don't want to put it with sulfur. It's already with that. So I'm going to find its new friend. I'm going to put it with iodine. Okay, I'm going to show my work up here. So I have NH4, I said is +1. Iodine is -1. Crisscross those. Okay, I get NH4I. All right, I'll figure out the state of matter in a second. I want to make my other compound. All right, so this time I'm putting together my second option, which is sulfur and magnesium. Okay, I'm going to show my work over here. So I have Mg's plus 2, sulfur is minus 2. All right, so those charges cancel out. It's not Mg2s2. Remember, these are going to simplify, and it's just going to create MgS. I'm going to go ahead and look at my chart. So I have NH4I and MgS. So I'm going to figure out which state of matter those are. So all substances containing NH4 are soluble. So we had NH4 there. That means that this is soluble, meaning aqueous. Now I need to figure out my MgS, because remember, if they're both aqueous, nothing happens. So I'm going to find the section that talks about S, which is right here. Substances containing S are not soluble. So that means that they are solids, except if they're with NH4, which it is not, or MgCaSr or barium. So let's go check. So we're going to go here. Oops. So it's with Mg. So that is going to be aqueous, which means that, again, this would be no reaction. So we wouldn't balance it. We just cross it out, and it would just be no reaction. If it was a reaction, so if that was a solid, again, because it said substances containing sulfur are not soluble unless they are combined with one of those, well, ours is combined with Mg, so that makes it the opposite, which makes it aqueous. So I'm going to have you guys try number 20.